So the name of our project is Smart Stick. It's a project we did for our microprocessor lab. So what will our project do? Our project will be implemented on a blind stick. The sonar sensor in the blind stick will calculate the distance from the blind stick and inform the person about any obstacle in front of him. It will tell him through a speaker or headphone the distance of the obstacle. For the speaking purpose, we have used text-to-speech converter and I mean text-to-speech converting code, and since we have used Arduino Uno, so we had to compile it in the Arduino IDE. Now let's get to the circuit diagram. You can see over here that we have the Arduino Uno and 3 sonar sensors. The sonar sensors are HCSR04 type. I will give a link in the description for everything we have used over here, and the code will be also there. Now let's get to the point. These 3 sensors are connected to the digital pin of the Arduino Uno. There are 4 pins in each of the sensors: GND, VCC, echo, and trig. GND and VCC are connected to the ground and the voltage source respectively, and trig pin is an input pin and echo pin is an output pin. Now we have connected all the pins in the digital input. The first sonar sensor's trig pin is connected to 2 and echo pin is connected to 3, and then the second sensors 4 and 5, and the third sensors 7 and 8. Now we have used a buzzer in our circuit because if for some reason the text-to-speech converter fails to perform, the buzzer will come handy. And when we get to code, you will understand why we are using a buzzer. And here is the buzzer. It's connected to pin number 12, and the speaker is connected to pin number 10. And you can power the Arduino with a 9-volt battery. So that's all from the circuit diagram. So that's how our circuit looks like. Here is the Arduino Uno board, which we have powered from our PC. I haven't connected it yet. I will connect it later. And here is the 3 sonar sensors which are used for measuring the distance. And here is the buzzer, which changes the sound intensity depending on the sound, depending on the average distance calculated from the sonar sensors. So this is really a brief circuit connection. I will explain it. I already have explained the circuit to you, and this is a really brief description of our project. Now let's connect it to the power cord and see what happens. So you can see that after powering the circuit, it's been there are some problems though, but the buzzer's intensity is the lowest. And let's keep an obstacle in front of this. Here you can hear that the buzzer intensity has increased. Let's see it again. I've taken away the file and the intensity has changed again. So that's all from our circuit perspective.
There is an obstacle within 179 centimeters. There is an obstacle within 179 centimeters. There is an obstacle within 48 centimeters. There is an obstacle within 10 centimeters. There is an obstacle within 10 centimeters. There is an obstacle within 10 centimeters.